I'm going to be talking about Windows Phone, XNA, games, fun, profit, and physics. We're going to go for about 75 minutes. It'll seem a lot longer, though. These are the jokes, folks. Okay, I'm going to get you guys to laugh if it kills me. And with that, he fell down dead. No, I've got a list of emergency jokes here, which I use when the going gets a bit tough. So we'll save those for a little bit later. What you're going to get from me, though... Oh, before I start, quick straw poll. How many folk here use Visual Studio? Okay, how many C# writers have we got? How many VB? Okay. How many XNA people have we got here who are already using XNA? 1 or 2, great. So I'm fairly sure I know more than most of the audience about XNA. I like that, that's good, that's a win. Okay, what you're going to get from me is a little bit of an overview of XNA, how we actually build games and what an XNA game looks like, and then we're going to move into how you can make more interesting XNA games with particular reference to adding physics. So we're going to have a quick play with the Farseer engine, and then at the end of it, a little bit about the accelerometer and how you use that to control Windows Phone games, and then finally an overview of the marketplace. So yeah, 75 minutes will seem, it'll just whiz by as though by magic. And to get things going, I'll tell you my favorite joke in all the world, which is a horse walks into a bar and the barman says, "Why the long face?" Okay, right, well, the others are even better. Okay, if you can bear that. Right, okay, so first thing, a quick overview of XNA. Effectively, when you build a Windows... Oh, one more question. How many folk here are writing for Windows Phone at the moment? Okay, great. You other guys have got such a lovely prospect, such a nice time to have. It's great, because if you've got studio skills, you're already able to write for phone anyway. So that's lovely, that's great. I'll show you how to get started, I'll show you how games fit together, and then we'll make some games and play them on the phone. As far as we're concerned, though, XNA gives you everything you need to create games. It's basically a new project type, which you build when you create your brand new project, and it does all the content management. It takes your images and deploys them to the phone. It does all the 2D and 3D positioning and animation, and you can write games either way, 2D or 3D. My advice, start in 2D with flat games, but you can do things to fake perspective by drawing little things further away and other tricks like that, which I'll talk about a bit later, and then move into 3D when you're happy with 2D. Most games, if you look at them, a lot of the big selling games on the marketplace are 2D. They might look a bit 3D, but most of them are flat. There are 1 or 2 exceptions to that, but the really big seller, Angry Birds, which is coming to the phone in May, as far as I can remember, that's a 2D game. That's one of the most popular games that we've got. What I'm going to show you is basically how you could make your own Angry Birds. That's a little bit later on. So we'll keep on going forward. As far as you're concerned as well, though, another big win is that once you've written an XNA game, you can deploy it on the phone, an Xbox 360, or a PC. You can use the same engine, the same behaviors, and maybe just tweak the assets a bit to rescale them, but you can deploy all this on any of those platforms. And that's really nice. You can have a single solution which contains a project for the Xbox, a project for the phone, and a project for the PC, and you can cross-deploy. So you can put applications out in the Windows Phone marketplace and through the Xbox Creators Club indie games. So there's all kinds of ways you can make a name for yourself. And the bottom bullet point, the last one on here, oh, there's me. Good God. Where did my chin go? Oh, moving on. It has a very well factored object model, which means that it's extremely easy to understand. If you've had a go with things like DirectX in the past or Direct 3D, they're fairly horrid to use. Whereas the way that XNA works is rather nice. I teach programming at the University of Hull to our first-year students, and I use XNA as an example of a well-factored object model, a good way to deploy resources. So it's a very nice framework. In terms of how a game works, if you've ever wondered, a game effectively does 3 things. The first thing, it gets your loading screen, which is basically I'm fetching my textures, I'm fetching my models, I'm fetching my scripts. That's when you have the progress bar going across the screen. And then once you've done that, the game then runs as fast as it can doing two things. It updates the game world. It moves all the objects, makes the car go faster or slower, checks for collisions, fires bullets, whatever your game is doing. And the second thing it does as fast as it can is it draws things. So effectively, it's taking this game world and putting it up on the display. And so once the content's loaded, the game just runs flat out, updating the game universe and drawing a picture for the player to see. And that's how pretty much every game has been made to go, okay? And so as far as we're concerned, it's easy. Because when you make a brand new XNA project, another project type, you can make a Windows Phone Silverlight program or a Windows Phone XNA game, then you just get a bunch of methods to fill in. And the methods are called initialize to set things up, load content to do the loading, update, which is your game world being updated, and draw, which is your game world being drawn. And that's it. So the name of the game, ha ha ha, almost funny but not quite, now I'll save the jokes for later, is to basically fill those methods in. So you start off with empty ones that draw a little blank blue screen, and then what you do is you go ahead and you fill the methods in. And so as far as we're concerned, that's what we're going to do. Quite a few of my games involve cheese. Somebody told me once that all great programmers love cheese. Now, I'm not sure this is completely true. If there's people in the road that write code and they don't like cheese, that's fine. You're probably very good programmers. I'll let you off. But that kind of stuck with me. And so I actually write games involving cheese. And this is a cheese rolling game, okay? And so what we're going to be doing here is we're going to be actually rolling bits of cheese around the screen for some unspecified reason, which will come to it. I mean, one of the ways you write games, one of the ways I write games, is I play with code. I figure out what I can make the program do, and then I start thinking, okay, how can we use that in the game kind of framework? And Cheese Roller, first thing we'll do is get some cheese rolling around the screen. And once we've done that, we'll think, okay, what direction can we take this? So I spend about a few days, a few happy evenings playing with code. I figure out what my game is really about, and I write that down, and then I sort of basically stick with that and add things to it. And that's how great games are made. I haven't made any great games. Well, I've got some games that I quite like. The worst thing about making games, actually, is that you make a game, and then all your friends beat you at it. So you've written the game, you know how it works, and they're playing it better than you can. I hate that. So I have trapdoors and things in mind so I can cheat and get extra thousands of points. But I digress. Okay, so we're going to make some cheese move. And what I'll do is I'll take you through an XNA project that does just this. And I'm going to sit down for this because at my age you have to sit down every now and then. Right, okay. Let's just drop across to one of my many projects. Let's see what this one says. Okay, so this is basically my cheese, and it's actually the wrong project. So we'll go and find the right one. Okay. Right, so this one looks good. Now, if you've heard about games, quick question. Can everyone see the screen okay? Is that all right? Can you see the words all right? Oh, gosh, you can see me again. Don't like that. Okay, make it a bit bigger. Why not? So I'll just grow the text a bit. Right, so if you're talking about games, you're talking about sprites. And a sprite in 2D games is basically a thing you put on the screen which displays some part of the game. And in programming terms, it's two things. It's a texture, which is the actual design of the sprite, and a position, which is where the sprite is presently being drawn. Okay? Now, XNA has types built in for both these things. And so what I have here is a texture, which is my cheese texture, and a rectangle, which has got X and Y position and a width and a height, which will show me where the cheese is going to be drawn. And when I build my empty game, I get a blank load content method. And all I've done, actually, one of my favorite jokes, what cheese is made backwards? Edam. It's on the screen. Right, okay. I think I'm wasted on you lot. Okay, but back to the... I quite like that. What cheese? You can use that one in the pub tonight, but it won't get a laugh because it hasn't done here. Okay, so I go off and find a texture file, which I've placed into my content. There it is, edam.png, which is just as you can see here. It's effectively, I drew it in Photoshop. It's basically a round object with a highlight. That's my piece of cheese. That's my PNG file. Getting objects into an XNA project is simply a matter of dragging them and dropping them. And once I've dragged and dropped it, I've then got an asset with that particular name I can bring in as a texture in this case, and it's called edam, and there it is. So once I've got my texture, that's my game assets good to go. If I had lots of textures, I'd bring them all in and store them in different texture variables. If I have sound samples to play when things happen in the game, we'll see that a bit later, then I bring those in as assets as well. If I've got 3D models, spaceships and rockets or whatever I've designed, then I can bring those in and store them as content in the game. This game, very simple, just got a single piece of cheese. And all I do with my piece of cheese is down here, in the draw method, I draw it. And so effectively, I have now, a little bit of graphics hardware background for you. The way that the Windows Phone works, the way that games work, is we have a piece of hardware, the GPU, that does the graphics, and a piece of hardware, the CPU, the processor, that effectively drives the game world. And the two things are kind of separate. And the idea is that the CPU, the processor in the PC or the phone, takes packages of commands and pushes them into the GPU, which then renders them for you. That means that we can run programs at the same time as our screen is being drawn. It works best if you batch up a whole bunch of commands before you send them. So you send one big transaction. And that's what happens here. Effectively, my sprite batch begin marks the beginning of a sequence of draw operations, and my sprite batch end is when it says, okay, I've got everything ready, now just render it. Okay, so at the moment, I'm just drawing one thing, which is my texture, and I'm drawing it from a texture called cheese texture at a position called cheese draw position, and I'm shining a white light on it so that I'm basically drawing the thing in its natural color. Now, you can have fun with this because you can change the color of things by changing the color of the light on them. So if things want to heat up or become cold, you can change the light to red or blue or anywhere in between and make them change in their shade, which is quite interesting. But that then just does the job. So if I now run the program, what's going to happen is the Studio will compile it, and then it'll push it down to the Windows Phone emulator, which is sitting down here on my desktop just here. And I see my piece of red cheese in the wrong corner. Okay? Now, the reason it's in the wrong corner is not because I am incompetent. There's a heaven forbid. It's because, by default, XNA games decide to start up with the phone held in landscape mode. So there you go. That makes a lot more sense now. I've got my rectangles placing my cheese at the top left-hand corner, 0, 0, and so there's my cheese being drawn. Now, I don't think it's worth a round of applause, and you don't seem to either, so that's absolutely fine by me. I think you've used up all your clapping right at the start, which is fair enough. But you've seen some cheese being drawn, and what I have now is, a little bit of Windows. If you've written XNA games before, there are some things it's worth knowing about the Windows Phone platform. Okay? By default, we wake up in landscape mode. So the player would hold the phone in the way that you can see it there and play the game that way. It's not the only way you can use the phone. You can tip it into portrait mode if you like, but the game has to know this, okay? And you can make your selections by adding these lines to the code. Oh, one point I should make, which I haven't already said. Everything you see, all the code, will be on robmiles.com/demos for you to download and use. So I'm not showing you anything you can't just take away and make use of tomorrow. So everything you're seeing, all the project, all the demos, it'll all be up there in code you can take away and use as the basis of games and play with. What I've got here is the sample code that tells the hardware, effectively, I want you to work in portrait, please, and I can do this scaling operation where I can specify the size, height, and width of the screen. And the final thing I'll do is I'll say, okay, I'd like you to be full screen as well, please. Because by default, an XNA game reserves a row at the top for system messages. So your screen will contain a row which has got information about battery, signal intensity, and some other bits and pieces, which actually steals some space from your game. And so what you can do is you can say, okay, please make the game full screen to actually get rid of all that. And so these 3 lines I tend to put in programs. And if you want to, something else which is kind of interesting, you don't have to do this, but if you want to, you can have a game that flips between landscape and portrait when the player tips the phone. And to do that, you have to bind to an event which is fired when the phone is tipped, because your game might have to rescale and readjust the positions of things in the game to make it work. And so, again, a little bit of code which you can use just to bind to the event is kind of nice, but I don't tend to do that. I must admit that my rule in Windows Phone game development is pick a size, pick an orientation, and stay there. Okay, because that works best for me. But this is worth mentioning. This is another nice little trick which is worth mentioning as well. Many years ago, when I was younger and even more good-looking, okay, no one can handle that thought. I used to write games for mobile devices, and it was a bit of a nightmare because you found that each device had its own screen size. Some of them were 320 by 240, some of them were square, some of them were the other way round, and it was a bit of a pain resizing and scaling your assets all the time to make them fit. Windows Phone takes all that away. It removes that problem completely. I tell the system how big I want the screen to be in my game, and the system sorts it out. I can go anywhere from 800 by 480, which is the maximum resolution, down to 200 by 200 square. And the system will just scale the image to fit the screen on the phone. And this is terribly useful. 2 reasons. One is it means that you can decide the resolution your game is going to have and never change that for any release of the phone, past, present, or future, because the hardware will always make it look right. The second reason why it's a good plan is you can get quite a nice performance hike by doing this. 800 by 480 is great for reading documents and high-res work, but for games, you don't really need it. You can go at a quarter that, 200 by 240. Is that right? 800 by 400 by 240, sorry. And the game still looks good. As far as your graphics hardware is concerned, it's now using a quarter of the memory to draw everything. And so what you can do, you get a lovely performance tweak by just changing the resolution down from the maximum to a smaller one, and your game will go faster. So you can do 2 things. You can make sure that you always work in the same sized environment, and you can twiddle with the speed. And so as far as the user is concerned, it's not noticeable. The scaling does it properly. In other words, it actually does aliasing and things to make it look good. And in a fast-moving game, the players can't tell. Now, lots of existing Windows Phone games do this, and it works extremely well. And I can show you this in action just by going back to my project, which is presently running in landscape mode 800 by 480. And we'll just drop back into my program, and we'll stop it. Now, this program, I've deployed it to the emulation, which is fine, but if I want to, I can actually deploy it to a real device, and I get just the same user experience. More of that a little bit later. If I go back into my initialize method, now this is called once when the game starts running, and effectively it sets things up. And here's the constructor where I've put my code, actually, so you can put them in either place, it doesn't really matter. And I'm saying, work in portrait, and make yourself 200 by 200, please, and go full screen. So don't give me the progress, the little status bar. If I run this up now in the emulator, then go back here. Now, my screen is now flipped, so the top left-hand corner is top left. There. Oops, wrong way, Robert. Getting there. And if you notice, it's now square, and the hardware's put black bands, top and bottom, to actually deal with that. So I've now got a much lower res, which will go a lot faster, and I've fixed the resolution and the orientation to suit whatever game I'm making. So the good news for developers is that you don't have to worry about resizing your assets. You don't have to worry about future versions of the phone needing new versions of the game. You just pick a size and you stick with it. And you can even scale your assets to fit that exactly and then just have it always work, which is really rather nice. So I'll stop that from running, and we'll go back to the slides and see where we are next. So let's stop that and then go back to the slides. So there you go. That's easy to do. And again, sample code is all up there for you to play with. As far as I'm concerned, yeah, I've got this game world. Now, what I'm going to be doing is flicking the cheese around the screen and making it bounce off stuff. Okay? Now, I had this vague idea of like a shuffleboard type game where you hit things towards scored areas at the top, and the closer to the top that you get, the better the score you get. And so the players would basically be like shove halfpenny or some kind of these little pub games where you find things about, or desktop or deck quoits on a ship, that kind of thing. So what I have is a draw method, which draws the cheese where it happens to be, and an update method which has a very, very simple physics model, which takes the velocity of the cheese and adds it to the current position to make it move. Okay? I've also got a friction variable that lets things slow down a little bit. And what I'm going to do is, having got this, and I'll show you the code in a second, I'm then going to start using the touch screen to fire things around. And what I want you to understand from this is just how easy it is to actually control things in a game using Windows Phone. Again, you get all the code, there's no problem there, and it all just works. Now, the touch screen is the only way. Well, that's not quite true. There are no buttons you can press to control a game. If you write an Xbox 360 game, you get this rather nice gamepad. You can twiddle and press buttons and all kinds of stuff. That's great. Windows Phone, you get a touch screen and the accelerometer, and that's it. But you can do some really nice things with this. The touch screen can track up to 4 contact points. I was thinking that 4 points doesn't sound very many. I'd rather have more than that. If you're holding the phone in one hand, 5 is probably the maximum you need. So 4 is just fine. And you can detect when your finger hits the phone, when your finger moves around, and when your finger is lifted off. And you can get you can basically pull messages in when any of those things happen. So XNA can do that for you. And if you fancy writing some code that uses touch points, that's fine and dandy and very manageable, easy to do. But XNA makes it really, really easy because it also has for the phone built-in gesture recognition as well. So we can tell the hardware, hey, if someone does a flick action on the phone surface, tell me about it and give me the direction. And that's what we do here. So effectively, there's a whole bunch of gestures. I can telling people about gestures sounds a bit rude, but no, not really. There's a whole bunch of different gestures you can pick up. Tap, double tap, hold, drag, pinch, and flick. We're going to use flick because it's really easy to get hold of. So all I have to do in my game is say, okay, Mr. Touch Panel, enable the flick gesture, please. Now, the touch panel will track flicks for me, okay? And you can ask the touch panel other things like how many points can you track and all kinds of good stuff like that. And this is effectively the code which you have to add to your game to be able to flick things. Now, what I've got here is if we have a gesture from the panel, we go off and get it, and if it's a flick, we get a vector and we effectively divide the delta, which is the direction of the flick, by 100. I'll show you what that, I mean, it's kind of tricky to sort of explain what's happening, but the code makes perfect sense. What I found when I was flicking my cheese, which is not a phrase you hear very often, was that if you flicked it and put the delta value straight in, the cheese went far too fast. So I had to divide the delta value, which the touch panel gives me, by 100, and that actually got the speed about right. This is called play testing, and it's great fun. And it's kind of worth recruiting someone to do your play testing for you, because it's quite an important part of game development. So here's my new game. Again, you can have all the code for this. It's all there. I've slightly changed my game because although I'm using a rectangle to position the cheese, I'm also using a vector now. So I have a rectangle which tells me where the cheese is going to be, and a vector which holds its position. Now, the nice thing about vectors is they hold floating point values, whereas the rectangle I can only position on pixel boundaries. So I have a little bit of code in the draw method I'll show you in a second or so, which sorts this out. But effectively, I've got a texture, I've got where it's going to be, I've got a speed value, and that's my friction. Okay? And that's it. If I go into my update, then drift down here a little bit further, then I figure out, this is effectively my physics model. Now I could actually just gone position, cheese position plus cheese speed, because you can do additions, but I thought I'd actually show you the add method being used. And then I get my position by adding the speed on. I take the speed and I multiply it by friction, so it slows down. And then here I do my flicking, that's my flicking code. And then here I take the vector and I set the position of my draw rectangle to the nearest integer. So this is where I convert my floating point vector x and y values into the integers that are going to place my rectangle. The final bit I do down here, this is my bounce. When the cheese hits the edge, I want it to bounce off. So effectively, if my x goes over the left-hand edge, I must flip the velocity to go the other way. And if the y goes off the top or the bottom, same thing. So I've got some bounce code here. But really, when you've seen this update method, you've pretty much seen all of it. And I'm asking the hardware, hey, how wide are you? So that we can get it all to work. So now, if I run this program inside the emulator, blimey, the Martians are coming. That reminds me of a really rude joke that I just can't tell. So we'll move on. Actually, I haven't had a joke for ages. There's a friend of mine is going out with a girl who's got X-ray vision, but I've no idea what she sees in him. Right, okay, fine. Laughing in spite of yourselves, that's what I like to hear. So here's my cheese flicking game, and if I flick the screen, the cheese actually bounces around. Now the nice thing about this is you've seen the code. Okay? There is nothing else happening. This is just how it works. If I give it a good flick, then, and I'm flicking using the mouse, but it will work just the same on the phone hardware, just the same. And you've seen the code. I took a bit of time to get the flick value right, but there you go. But what we can do now is the thing which is quite nice. I've got the program running inside the code. While it's running, I can slap a breakpoint in here. And next time update is called, we get our breakpoint hit. Now, one point I haven't made up until now is that your update and your draw methods are called automatically by XNA 30 times a second. So what's happening is that 30 times a second, we're updating our game universe. And 30 times a second, we are drawing our game universe. It runs a bit slower on the phone than on the Xbox 360 and PC. They run at 60 hertz. But on a phone with a smaller screen, they've reduced the power requirements by dropping down the update rate to 30 hertz. Okay? So this gets hit. If I run past this breakpoint, it'll hit it straight away again because I'll get called in the next tick. There you go. I'll get called again. And so I've effectively got the outside world, the XNA framework is calling my draw and my update methods for me, and it's my job to basically update the model. So 30 times a second, we update the position of the cheese, we look for gestures, and what I can do while I'm debugging is I can have a bit of fun. Now, at the moment, my friction variable is 0.99 because I want things to slow down. Watch what happens if I do this. Equals 1.01. I've now got a table which actually speeds up. Friction, oh, hang on, okay. I've got to put an F there, Robert, thank you. So now my friction is now bigger than 1. So what happens now if I get the thing going, and I'm hoping it doesn't actually go too nuts before we get onto the emulator. So I'll give it a flick. Oh, it's still there. Thank you. There's a bloke at the back who's more awake than I am. Kill the breakpoint. Put this, go back and get this. And then if I just do that, and then, oh, for a bigger taskbar. What do you want for Christmas, Rob? A bigger taskbar. Okay, still won't let me do it. Right, okay, get out of the way. I want you to see it because I think it's going to take off like a rocket when I do this. There you go. It'll get faster and faster and faster and faster because now friction is actually speeding my ball up. And after a while, it's going completely nuts. Now, the interesting thing about this is that the same thing would have happened if I was debugging inside the phone. Okay, so now it's gone completely and utterly bonkers, and I probably better stop it before something terrible happens and the ball escapes from here and crashes into the ceiling. Although that probably won't happen. But you can, I'll just, did I stop you? No, I didn't. What are you doing? Have you stopped by yourself? No, you're still going. Do-do-do. Oh, I think I've confused myself. I do this a lot. This is the one I really want to do because this one's running. Stop. Thank you. So it goes away again now. But the nice thing is that I can do all those lovely breakpoint, immediate mode, change stuff, run it on when the code's inside the phone device. So I can debug my programs as if they were on a desktop device, but in fact I have a phone and the end of a cable. And so I can do all the good stuff, all the debugging, all the playing around my programs, exactly as I would on a desktop, but it's happening inside the phone. And that goes across all phone development. It's also true for Silverlight development too. So you can do all the nice things actually from within Studio on the code itself. So the thing about this as well, if you ever wondered how video games have got, if you're playing a racing game, you'd go over a track that suddenly speeds you up. Mario Kart does this. It has like chevrons on the thing and go whoosh off those real fast. Now you know how that works. They just, as soon as you hit the chevron bit, it makes friction bigger than 1, and your car goes wham. When you get over that bit, it goes back to 0.9 or something, so slow down again. So it's quite nice because you can see how these things work. So now I could have an area of my screen in my flicking game where the cheese suddenly sped up. That would be really easy to do. So this is what I was saying about meddling with code and fiddling with behaviors to see what they do, because you can do that. And XNA is great for that. But all I had to do to get my cheese to go in the direction I flick it is take the delta value out of my gesture and apply it to my cheese speed. And I divided it by 100 to get a kind of a reasonable amount of feel on there. So there you go, there's my rolling cheese, and you've seen it do it. And it all worked a treat, but nobody clapped because life's like that, Rob. So, moving on. I now want more cheese. Okay, more cheese. That sounds great. Grommet. And so, to do that, you see what I wanted, I'm thinking about this, I'll have lots of different types of cheese, and we'll basically, 2 players will take it in turns to hit cheese into the score area and knock each other out and move. So now I've got a kind of bowls type action going on, but you could also go for snooker, billiards, any kind of ball game. You've got most of the mechanics there, but if you want to have lots of balls in your game, then you have to handle their collisions and deal with the physics properly, and that sounds to me too much like work. So I do what I normally do when I find something that's a bit hard to do. I'll go off and find some code to steal and use. And the one I'm going to be using and showing you how to do things with is called the Farseer engine. And it's a really good 2D physics engine. I was actually at Mix a few weeks ago, and I met the guy that wrote Farseer, and I shook him warmly by the hand, and it was really very embarrassing. So we'll move on. But it's a smashing little 2D engine which you can use to create games which have an element of physics where you want things to collide and bounce off and behave. And it kind of hides all the hard work, all the tough stuff from you. And so if you haven't done physics before, you're about to. If you've done XNA before and thought, how am I going to get physics to work, this will be very useful. The code you're going to see, I'm going to give you, so you can just take it away and make any kind of game that you would like. To find out more about this, go to Codeplex, Farseer Physics. They've made a version 3, but I'm using version 2 because I got that to work with the phone and it makes me kind of happy. If you want to start with version 2, then just take my code, robmiles.com/demos, and pull it down and use it. And I made this isn't cheese-based, which is kind of worrying. It's basically a very simple destruction golf game. Last year we had a student programming competition, and I gave the students some code to play with, and I said the name of the game is Destruction Golf, so go away and make something. And 15 teams went off and had a go at this, and one of my students, a guy called Harry Overs, took my Destruction Golf code, made a couple of levels, slapped it on Windows Phone Marketplace. He's had well over 10,000 downloads. It had a lot more than I've had with any of my games. Which is a bit depressing, but there you go. So there's a nice sort of trajectory there which you can follow. But the idea is that effectively I'm going to put some objects into my physics engine, and it will look after where they are and what happens when they collide. And it all goes as though by magic. And as far as we're concerned, a couple more things to learn, bodies and geometries, and then all the hard work is taken away from us, and it all just works. It binds itself into XNA, and then off it goes. We create ourselves a simulator. There it is. The vector, a value of x and y, gives the direction of gravity. So this particular golf game is being played with no headwinds, no x value, and a gravity of 250, which is pulling things down. If you want to play a round of your golf game underwater, where stuff goes up, then on the moon, just change that value there. Make it minus 250, and the ball will now go towards the top of the screen rather than the bottom, which is kind of fun. You can play with these things. But as far as I'm concerned, first round, keep it simple. Gravity goes down, and there's no wind. Okay? Absolutely fine. So here's my stuff to make it all go. Effectively, I've got a texture for my shelf, a texture for a body and a geometry, and a position. And these are things I'm going to use to place in my Farseer universe. The way that Destruction Golf version 0 works is that I have to knock things off shelves to get my ball into place for the next shot. So I'm going to place my little target. And I've done some really impressive graphics for this. It took me ages. I've drawn this fantastic, wonderful piece of artwork for the house. So I want you all to cheer and clap when you actually see just how good looking my artwork is, okay? But the house sits on a shelf and the ball hits it, knocks it off the shelf and onto the next level. That's how I'm doing it. This is my shelf. That's my texture, which is just a picture of a shelf. That's where I'm going to place it on the screen. No, sorry, I apologize. That's the part of the shelf about which it will rotate. If you have an object in a physics engine, it will have a point about which it spins. If you've done physics back at school, you'll know about things like center of mass, the point about which the mass of the thing appears to operate. That's what that is. And I've slapped it right in the middle of my shelf. Okay? I've then made myself a shelf, nailed it to the wall. It's static, so I can't move it around, and placed it in 3D, in my 2D space on the screen, and then add it to the simulator. So I now have a shelf on the screen. Wonderful. This is the geometry. The two things that are interesting here are the restitution coefficient, I can't see, which is how bouncy it is, and the friction coefficient, which is how slippy it is. And you can play with these, and it's great fun. So you could have really bouncy golf balls in one level and really hard golf balls in another. You can have you can have ice. You can play one round on ice and one round on grass, which is much more frictiony, to use a technical term. And so you can play with these. This is what I was saying about making a game engine, figuring out what it's about, and then playing with it. Okay? And then I just draw my shelf. Sprite Batch is my drawing machinery. You've seen the draw method before. This is a much bigger version, which has a position and a rotation and a few other parameters. Again, don't worry too much about these. Just steal them. Just use my code. It will work a treat. The shelf doesn't rotate because it's just holding up my house. The ball and the house will spin. And so here's my little house. And I do the same thing with this. I give it a body. And I'm giving it a mass of 3, which again is another number you can play with, which is kind of fun. That 3 there is how heavy my house is. If you make the house really light, the ball will just blow it away. If you make the house really heavy, the ball will bounce off it and the house won't move. We'll play with that in a second. So you might want to play with these numbers, and then you basically put the ball on the screen somewhere, and then we're going to flick the ball like we've done before, and the ball will then just start moving across the screen. And so I'm using my touch flick gesture again, and I'm using this method called apply impulse, which basically says kick it in that direction. And I take my gesture and I fire the ball across the screen. And a little bit more before we get to the really exciting bit, which is seeing the code and my wonderful graphics. When two things hit each other, you want your program to be told about them. And so I can bind to collision events which the objects will fire when they hit each other. So what I can do now is I can get my game to do something when the ball hits the house. And what I wanted to do is go bang. So I've got a method here which effectively handles that, and here it is. And what happens here is that the method gets told the two things that have collided and a list of all the contact points. I don't really care about that. I just go, okay, if we're playing a sound, don't do anything. if I've hit the shelf, don't do anything. Otherwise, set the sound active to true and play a bang. And this is all my code that effectively just deals with the fact that when the ball hits the house, I want to hear an explosion. Now, you could do other things. You could increase the score. You could knock a life off the alien because you've hit the alien one time and all that kind of stuff. So you can do what you like. But all I'm doing is going bang, because that's what my code should do. And there you go. That's what that slide's on about, really. We're just not playing the sound if we hit the house. And then, final thing, before we get to see my wonderful clip art, we have to update our simulator. And again, these numbers are the numbers that I've got from playing with that seem to actually work quite nicely. And so for the purposes of my program, these values at that point, 0.005 seems to work okay. There are weird things with physics engines. If you get things stuck inside things, it can go a bit nuts. So you have to play with these numbers a little bit carefully. But I've got them to a point where they make a game which is kind of playable and a good starting point. Okay, building up the tension, even more exciting. If you've ever played a golf game, you find that actually you don't just use the width of the screen. You use a sort of scrolling screen. Okay, so you fire things and they go off the screen, and the screen then scrolls to keep up. I do that here. What I'm saying here is that if the ball starts to get off the right-hand edge, in other words, if the X position plus my scroll margin is bigger than the width, then I just create an offset value, which is effectively taking my ball and my margin, and I'm going to push the screen across to track the ball. Again, don't worry too much about the code because the program shows this very effectively. But the next thing which you can do, having done that, is you can create a transformation matrix, which is basically a lump of data which describes something you want to do with an image. And I'm just making one which is a translation of the value of X and then nothing in Y and nothing in Z. And one of the nice things you can do in XNA is you can transform your drawing operation using a matrix like this. Now, that means if you want a game with a play field that's bigger than the screen, then absolutely make a great big texture and then just move the viewport around within that. And you can do that just by using this transformation matrix technique. I'm only scrolling to the left. I have a long, thin texture, which I'm going to move through. But you can go either way. And that's the drawing with transformations, which when you begin the drawing method, you just say, okay, there's my matrix, there's my transformation there, just do that. And finally, there's my house. Isn't that amazing? Yes! You're going to want to see it work now, though, which is the scary bit. So, cheese smash. I put cheese in the name because I was thinking I was going to start firing bits of cheese at this. So I could actually do that. But I'll just target the output to the emulator, and I'll fire the game up. Now, everything you're seeing is the same code that I've shown you in the talk. Now it's, oh, wow, I've got a message. My phone's funny. And this is basically destruction golf, okay? Now, the idea is I can flick my ball, and you don't flick my ball, and blow the house off the roof, and then my ball just goes down there, and then it resets. So the idea is the player will actually not quite do that. If I go a bit more gently, then I can actually blow the house. The ball will come down in a minute. And the way I've got the game written is when the ball comes back down and falls off the bottom of the screen, come on down, there you go, wee, bonk, it resets. And my house drops back into position. So one little thing you notice about physics-based games is you don't want to have things starting off touching. You have to have things slightly separate, have them drop into place. That's what my program does. So the idea is that if I get this just right, and I haven't, that's rubbish. So now it goes all the way, and I'm scrolling happily off my, and guess what happens there, people? And then I obviously fall off the screen. Let's try it again a bit more gently. So doink. Oh, that's rubbish too. That's going to fail as well. So another one, doink. Perfect. The idea is then you see there's another level further up, and I then flick the ball at that one, and I work my way through. And it doesn't look a bit like Angry Birds at all, really. But the bottom line is, if you wanted to make something which looked a bit like this and worked in this way, you've got all the code. All you need is more assets, make a few more bodies, and drop them in. At the moment, I've only got 3 things: the ball, the house, and the shelf. But you can have as many as you like. I've got up to 40 or 50 objects on the screen of the phone bouncing off each other, and it actually works very nicely. One of the things I made, and I actually had this running on the Zune of all things, because the Zune supports XNA as well, only version 3.1, unfortunately. I had about 26 Scrabble tiles, letter tiles, falling down and bouncing off each other, and it all worked extremely nicely. So there's all kinds of places you can use a little bit of physics to make things more interesting, but I kind of like this. Except that that didn't do anything, so I missed again. One more try. There you go. And as I said, you can fiddle with the mass and the restitution coefficient and all that kind of good stuff. And your program can, of course, use the position of things to decide what to do next. So if my ball stops on that thing, then I go level up, and we move on to the next one, and the next one, and the next one. But feel free to take the code, mess around with it, do what you like, because it's all just there for you to play with. So I'll stop that using the stop button. That will work better, Rob, and go back to my presentation. So you've seen Destruction Golf and even clapped. Thank you very much. That was lovely. So final thing I want to mention, well, 2 more things actually. So one of them can't be final, can it? Anyway, yeah. I've decided to make some musical bread, but I've only got the dough so far. Okay, right, fine. You got the dough so far? Yes, the phone accelerometer. Okay? This is how you get input to your game from tipping. We've seen how we can use gestures. They're very easy to use. What I want to do now is show you how you can use the tipping motion of the phone to actually control the game. And this means we have to use the built-in accelerometer. Now that gives you acceleration values in X, Y, and Z. Okay? When you hold the phone horizontally like that, then you can imagine a lead weight on a piece of string hanging down underneath. And so the phone at rest in portrait mode has an acceleration of 0 in X, 0 in Y, and -1 in Z. And as you tip the phone and the weight swings, you can kind of visualize what happens to the position of this thing in 3D. As I tip it up, once the phone is vertical, I've now got -1 in Y and 0 in X and Z. And so effectively you can use this to actually measure the orientation of the phone as well as the acceleration. You get acceleration values when people start to shake it. If you want to make a game where you shake the phone to make something happen, there's a very good DS mini game where you have like a bottle of champagne and you take it in turns to shake it until one of you makes the cork pop off. If you do that, then you start looking for acceleration values bigger than 1. And I think I got it up to 3G by shaking it. I kind of got scared that if I shook it anymore, it would fly out my hands and stick in the wall, so I didn't get beyond 3. But you can have a game where you can shake the phone as hard as you can, and you can track the acceleration value. You can get the magnitude of the vector and figure out how hard it's being shook, which is interesting. But I tend to just use it for tipping games where I've got this 1 hanging down, and then as you tip it up, it changes to different axes. If you've used the XNA gamepads on the PC or the Xbox, you can, with a bit of simple maths, convert very easily from gamepad input to tipping input. Very easy to do. So, as far as we're concerned, it gives us a number that tells us the orientation of the phone. Using it, not quite as simple as we might like, because unlike everything else in XNA land, the sensors are handled on an event-driven basis. If you're a Silverlight programmer looking at XNA, then there's a certain amount of mental readjustment you're going to have to make. Now, the issue is that in Silverlight, everything happens on events. Stuff happens and your program responds to them. Okay? In XNA land, pretty much everything happens by polling. You get called, update runs, it goes off and looks at the state of the inputs and adjusts the game to suit that. And then you've finished, and then you wait for a while, and update gets called again. And so there's no events as such. You're just repeatedly called. In the graphics side, you're not worrying about moving things around and redrawing the background. In the drawing side, in XNA, you basically tear down your image and draw a brand new one every time, 30 times a second. And that's because that's how the hardware likes it. Okay? But for the accelerometer, at the moment, you have to use the sensors library, which comes from Silverlight in your XNA games. So you have to effectively do an event-based piece of jiggery-pokery to get the event fired into your game, and your game can then use the accelerometer. And here's the code that we just have to add the sensors device to our project. These are all the other XNA library elements. And then, having done that, I can then create myself an accelerometer and then bind to the events it produces. Okay? So here we go with that. There's my accelerometer. When I get a reading changed, I call this method. I'm sorry about the layouts, you've got a bit wibbly, but that's the method I'm going to get called each time. So make an accelerometer, bind to the changed event, start it running, and so now every time the hardware in the phone gets a new value, it's going to actually fire my event to do something with it. Okay? So that's easy enough. And all my method does is it gets the X and Y and Z values out of the accelerometer. Here they are from the event args, X, Y, and Z, casts them into float, and then sets up a little vector, which I'm using to pass information from the accelerometer event handler into my game engine. And there's a final little wrinkle, which is that I use a lock, because I don't want my accelerometer code and my update code, which are running on separate threads, to actually conflict. Okay? So the idea here is that I'm going to lock onto this stuff, and so while I'm doing this, I can't be interrupted. And the idea here is that when I want to get the values back, I just do another lock. And so here, I get the acceleration for the X and the Y values of my, cheese. I've got more cheese in the game. Of my piece of cheese, I get from that vector. Now, I'm doing a bit of very simple physics here. I could use fast here, but to be honest, what I'm doing is actually very simple. Don't need to do that. So I've got a little bit of code that takes the tip of the phone and uses that to control the acceleration of the item in the game. Now, this is a kind of lunar lander type thing, where I want to tip the phone and try and land things. And so I'm going to be using the tipping of the phone to control how fast things move. Now, any kind of tipping control game, just pick this code up and use it. It will just work. So these are now very easy to make. So I didn't use the farseer for this bit. I just did it all straight from within my my own little program, my own little physics model, which is basically just two vectors. And so here you go. This is the world-famous, notorious cheese lander program, okay? Which is where you have to land cheese on bread. The interesting thing about this one is that I can't show you it on the emulator because I can pick the PC up and tip it. It's not going to have much of an effect on the thing inside. The next version of the toolchain, which is going to come out along with Mango later this year, actually has a proper emulation of the accelerometer. So you'll be able to tip an image of the phone on your PC screen, and your game will get inputs to match. In fact, the emulation story for Mango is going to be fantastic because they're also making the emulator location aware. So you can effectively touch locations on a Bing map, and that will move the emulated program into that particular location. So if you're making location-aware code, really, really easy to test that. In fact, you can even create paths which you can follow and have your game or your program or whatever pick up the information from those. A few years ago, I set students a little exercise for mobile development where they had to make a program that makes sure you're never late for a lecture. And the idea was that it would figure out where you were, it would know where the lecture is, and it would say, okay, start walking now, and the alarm would go off, you see. So the idea was the further away from the lecture you were, the sooner the alarm goes off. And we were watching students test this, and they were walking around the campus like this and thinking, I'm testing my program. Now you're being an idiot. What you have to do is do that precisely once, get a bunch of sat-nav readings, and then just feed them into your program to fake it. Now, they had to write the wrapper code to do that. On the next version of the emulation, it'll all be done for you. So you can effectively move things around. One of the things that, if I've got time, I'll show you on the end. I might have a few seconds at the end. If not, take a look at some of my demos. It's extremely easy to get hold of an image from Bing Maps and use it in a game. In fact, there's a game out there based on it, Crackdown 2 Project Sunburst, that uses location images in the gameplay. It's really, really easy to do that. In fact, it's very easy in a game to pull down images from anywhere on the interwebs and use those in your gameplay. So you could have a website warriors where you take on a website and shoot down all the icons. Because you can, because it's easy. But enough of all that. Let's land some cheese, to coin a phrase. So I'll go back to, I've gone too far. Cheese smash, cheese lander, here we go. Now, when you build your project, you decide where to deploy it. This project is being deployed at the real device. If I fire it up on the emulation, it runs fine. It's just the phone is never tipped. It's always the same orientation. So here I've got my position, my speed, and my acceleration. I also have a threshold, which means if I land the cheese too quickly, then the game is over. And I have a texture for my piece of bread that I'm landing on, and a texture for my star field at the back. I don't know why it's a star field, but what the hey. And then I have textures for the cheese and also some messages. Here's my accelerometer. And this game is well worth a good look because it performs proper game state management. So this game is actually in marketplace. You can actually buy it. But 5 people a week buy Cheeselander, which when you see it, you'll be amazed it's 5. But it's been through certification. It's a proper formed game. If you start making a proper game, you'll find that basically it's a state machine. And at any given instant, your game is in one of 4 or 5 different states. And the states I've got, I'll make them larger so you can see them properly, are showing the title screen, playing the game, paused, someone's won, someone's lost. And so my update and my draw method are basically switch statements. And the idea is that I go into update, I just have a switch on the game state value, and I then just go off and do that behavior. And when we hit the bread and we win or we lose, I flip to the won or lost state. When they press the back button, I go into pause, and when the game starts, it wakes up in title. And so it's effectively a state machine. Now you can pick up this and use it as the basis of anything you like. Other thing I'll mention about games that make this more interesting as well, to put a game on marketplace, it has to behave correctly when you turn it on, when you pause it, and when the game itself is terminated by an external event. And I've got all the code in that does that as well, so you can effectively pick that up and run with it. So without further ado, because it just gets too exciting otherwise, I'll deploy this to the phone. But it won't work because my phone is presently locked, so I'm now going to get an error. Come on, tell me the error. Come on. Bang. So I have to unlock, I have to wake my phone up. So I just do that. Dismiss my, apparently I'm doing a lecture now. Who'd have thought it? Remove the screen. You'll see that in a second. And now I just say, I know about that. No point in continuing. Run you up again. So now the program's being pushed down the wire into the phone. If I change to the visualizer, then it's on the programs list at the moment. It's going in there, deploy started. It's taking all the textures, all the sound effects, all the stuff, and pushing them into the phone. And in a minute or two, Cheeselander will start running. And there you go. This is so exciting. And if I just zoom out a bit, you can probably see it a little bit better. Right, so that's Cheeselander, right. So effectively, I'm using touch events to get the game going. So touch the screen, touch the screen, touch the screen. Hey, it stopped. Really? Okay. Oh, we're going now. Now, if you can see that, the cheese is at the top, the bread is at the bottom. If I tip this up, the cheese starts to fall. If I tip it back the other way, the cheese will slow down. And if I tip this down very gently, the cheese will head for the bread. Just tip it a bit further that way. And if I get this right, okay, too fast. So that's it. That's cheese. Press it again, and now try again. And there's normally about a 3-hour break now, or Robert fails to play his own game properly. So if I just turn the engine off now, and just do it very, very... There you go. That's how you play Cheeselander, folks. Now, that's it. People pay 79 pence for that, and good luck to them. If I touch the screen, I can restart it. If I pause the game, if I go back to the start menu, my Visual Studio project will pause. I can then actually go back to it and resume it like that. And the visual debugging environment will start up again, and I go back into pause mode in a second or two. There you go. So I press back, and I can start the game again. Bing, and do it again. The timer this is version 2 of the game, where you have like a time you have to land it by, but haven't quite got that finished yet. So what you have here is kind of like a work in progress. If I go into here and just hit stop, then I drop out of the program and go straight back to the previous screen, and away you go. So deploying into the device is very, very easy to do, just like that. The game is now stored on this device as well, so I can go back into here, and if I go into the programs on the device, oh, that's me. What a horrible picture, Robert. Get out of it. Boink. And then I go into here. I've set icons for this, and away we go. And that's the game running on the device. So it's easy. You can steal that code, and if it makes you rich, then you're a better man than I am. Good luck with that. And what I'll do now is I'll continue on for the last 10 minutes or so with the last little bit, and then we'll stop, and I'll go have a lie down. So, final bit of the story is how we put programs out there for the unwitting public to rush out and buy. And the idea is that everything on the phone is done in a managed way through the marketplace. So it's like another phone whose name begins with I. You'll never guess. It's managed in a very similar way. Developers sign up on an annual basis and get the right to put applications into Marketplace, and each one that they put in there is vetted against a whole bunch of guidelines to make sure that when the customer buys this thing, it ain't going to steal their passwords or crash the device or flatten the battery or make it catch fire or track everywhere they go. Who would have thought a phone could ever do that, eh? It's just there using a particular set of resources and mounted on the phone. And so the idea is you register, and then once you're registered, you can submit applications to the marketplace, and you can also unlock devices for development. A standard Windows phone you buy in the shops and sign up for a contract will not accept applications from Studio. There's an unlocking process you have to go through, which is managed via Marketplace, and developers can do that to 2 or 3 of their phones. It costs you $99 a year. It's all done via your Windows Live identity. And if you're a student or have a kid who's a student, you can, I didn't say that, but I could hear you thinking it. I don't care if she's doing history of art. She wants to write games. The DreamSpark project allows students to actually sign up and get Marketplace membership for free. And they can unlock just one device, but they can publish apps like everybody else. Loads of our students in Hull are actually doing this now. And my friend Harry, with his 10,000 downloads, you go on the Marketplace, look for Destruction Golf, it's there. He's had more hits than I have. Look for Cheeselander. That's there too. And there are a couple of other games of mine as well. But the idea is that once you're out there, you can then start deploying your applications and your games to the platform. I tell my students they're probably not going to get rich doing this, but it gets their name out there. If they want to go and work for a game publisher when they graduate, if they can wander in and say, okay, I've got these 3 games out, they're getting reasonable reviews, fair number of hits, that marks them out as better than the other guys. And so this is a great way of promoting yourself as a student. It might be that you write the next Angry Birds. Fantastic if you do, and good luck to you. As far as I'm concerned, and this is really sad, but it's true, I would pay $99 a year just so I can put games on my phone that I can play. I like writing code. I buy all these Xbox games and I keep them at home in the shrink wrap and never get them out because I'm spending all my time making cheese bounce around the screen because that's what I do. But it's fun. I like doing that. So there you go. That's just me. As a developer, you can give away applications. You can give free ones away, or you can charge for them. You can give it to 100 away free, 100 different applications if you want to do that. And you can also, and this is a really good trick, you can make trial versions as well. So you can produce applications that have a trial mode, and you can detect in the game whether your program's running in trial or full-blown. And you can actually then have just the first couple of levels playable till they've bought it, or you can do any kind of sell-through that you like on that basis. If you publish in the States, you can actually make use of in-game advertising as well. That's not available in Europe just yet, unfortunately, but you can also do that as well. So there's all kinds of ways you can actually manage the manipulation of it. You go through a process to submit your apps. The way that applications are packaged is that the output of the compile and build process is a file called a ZAP file, XAP, and that's basically a zip archive with a manifest, and that contains all your assets, your executables, and the manifest, which states what phone attributes you want to use. You push that up to the marketplace. They then run a testing process on it, which is some automatic and some human, and they then come back to you with feedback on whether it's passed or whether it's failed, and if it's failed, which bits have actually not passed. I've had applications that haven't passed certification because I've done stupid things in assuming the way that things are supposed to work. You get really good feedback. They're extremely good at telling you what's wrong with your app. They'll say, menu 3, this bit here shouldn't do this, it should do this. Right, okay, I'll go in and change my state machine, fix that, and away we go. So you push that file up, you get your feedback. If it's approved, it goes into Marketplace. The process normally takes around 3 or 4 working days. It's very quick and works extremely well. They're very keen to get your apps out there, so they give you extremely good feedback. Once it's approved, it sits out there. You can push out upgrades. If you push an upgrade out, the user gets the chance to upgrade via Marketplace on their device. And the bottom bullet points on here are the ones you should pay the most attention to. There's a really good submission guidelines document, which you should read. It's well worth having a look through. It'll basically short-circuit the application process. I didn't read it properly, and my app got bounced, but that's just me. So read that, and you'll be fine. You get 70% of the fee paid. Once you've earned over $200, then you start getting money fed through to you. The payment process is a bit of a pain, to be frank, if you're from Europe. If you're in the States, it's great. If you're in Europe, you have to get some tax stuff sorted. But that's just a question of doing some registration, fun and games. And once you've done that, you can actually start getting money. The registration process does not affect whether you can submit apps. Cheeselander and all my other applications are out there attracting huge amounts of revenue, but I haven't yet sorted my tax thing out. So all this money is sitting in Microsoft's bank account waiting to come my way. So there you go. Maybe I'll buy a yacht. Maybe it'll be a Lego one. So we'll move on. So you can always submit apps. If you're a student and you're going through DreamSpark, really important tip. As soon as you've registered, submit an app. even if it's just a torch app or something very simple, because for students, the actual VeriSign authentication process, where they give you your own VeriSign certificate, that process only starts for students when they submit something. If you pay $99, then that process starts instantly. If you register as a student, they go, okay, we're only going to actually go through this process for those that register and do something. Students are legendary for not turning up, okay? You're organizing a party. Oh, yeah, we'll all come. Party arrives. No one turns up. And Microsoft know this, and so what they do is they say, okay, we're only actually going to give you your authentication process, because it costs a bit of money to do this, for free when you turn up. So if you're a student, get a game out there as soon as you're registered, and that'll start the process off. 70%, fair enough, that works for me. There's no other way I could get that kind of money, and so that's all the way it is. So what have we learned? Well, a couple of really good jokes. There's these two lions walking down the middle of Hull High Street, and one says to the other, it's a bit quiet for a Saturday, isn't it? Oh, okay, fair enough. I quite like that. So, what we all have also learnt, Windows Phone Platform provides a really good mix of resources. It's easy to use touch and accelerometer. Physics is easy to add as well. Publishing is very easy and very cheap. In my opinion, there's never been a better time to create mobile games. And you've never had such a good set of tools. Visual Studio is the best place to write code. C# is the best language, in my opinion. If you write VB, that's fine. There are VB wrappers for XNA on phone coming through. So you can think in terms of taking your VB skills and using those if that's what you'd rather work in. So it's all good, solid stuff. And it's a great place to work, and it works really well. In terms of what to do next, the URLs you should look for are create.msdn.com, which is the creator's website, and the most important one, which is robmiles.com, which is my blog. I'll show you my blog because I'm very shallow. I need the traffic, basically. There you go. So this is robmiles.com, and it has a bit of whining about trains that don't work, my schedule, all kinds of other stuff. But if you do the sensible thing, which is just to add the word demos on the end, robmiles.com/demos, then what you get now is effectively everything you've seen today, plus a whole bunch of other stuff as well. The Windows Phone Blue Book is 180 pages of PDF, which basically tells you how to write code for the Windows Phone. It's got a fairly strong Silverlight focus, but there is actually a section on XNA as well. Silverlight is worth spending some time on, because at Mix, Microsoft announced that the next version of the phone software, codenamed Mango, will let you combine Silverlight and XNA programs in the same application. Now, one of the problems with XNA is that you can make menus, and you can make buttons, and you can do your UI, but it's kind of hard work. You have to use textures and touch events, all that kind of stuff. Silverlight is great for UI. But its game behavior is a bit slow because of the way it renders. It doesn't go as fast as XNA does. So what you've got coming down the tracks is the best of both worlds. You can get a developer who's good with Silverlight and good at UI design to do your menu side, and then you can crack on with the XNA side and make a game that plays really well, and you can marry them together. The developer tools for that are coming out fairly soon. So it's well worth taking a look there. But here, Windows Phone has some Silverlight that'll get you started there, and XNA. If you want to learn some C#, take a look at my yellow book, and then here I've got a whole bunch of different XNA demos, including the ones you've seen today, and other ones that do things like load maps from Bing Maps and display them in Windows Phone games. There's all kinds of good stuff there. Please go along there and take a look. I've got 39 seconds left before I get to run for the door. I can see the clock, it's kind of scary. But thank you very, very much for being a tremendous audience. Those are the things there. So if you have any questions, go down to the front and feel free to ask them. But thank you for being a great audience. Don't forget your evals, and thank you very much.